This is a basic demonstration of Geomagic Essentials and how Geomagic Essentials can extract CAD information and send it over to Solid Edge. So on screen you see that I have a fan blade that was scanned, and this is the kind of data, this is how it will come up inside of Geomagic Essentials. You already have a polygon, and in many cases you don't really have to do any cleanup, but I left some of the uh, data to clean up so we'd have a little bit of time to demonstrate how I would remove areas and repair the mesh before extracting CAD information and sending that over to Geomagic Essentials. So as you can see, I put the fan on top of this sphere. So if I want to remove that bottom area, I can just look at it from the side, and I can grab tools from on the right-hand side over here. In this case, the lasso tool, and then I'm going to change it over to select through. Now with this, I can come in and just window in and select through, and you'll see that it will go all the way to the other side. And then if I just hit delete, I can remove those areas. And if I want to do it again to get a little bit of that edge, get a little closer, I can do that. So if I just come in and select and then hit delete there. There's a few different areas around the part where there's some defects. What I like to do is run what we call the mesh doctor first, because what that'll do is it'll correct some stuff automatically and make less work for me. These 7 checkboxes here on the left-hand side are 7 different categories of problems that we find wrong with meshes that are scanned. And if I hit apply, it'll automatically repair those. But if there's any reason for me to look at those individual areas, I can hit this walkthrough mode, and they'll take and show me each one of those areas if I wanted to see it and evaluate it and possibly edit it on my own. So if I come over and I hit apply, the software will automatically repair all those areas on the mesh for me. Now you will notice that there are still some holes. Those green boundaries are showing that there are some hole areas that we can repair. So the next step after this mesh doctor finishes is then taking the data there and filling the holes for those green boundaries. So if I just give it a second longer here, it will finish repairing those areas. And you'll see it'll have all zeros there. So now if I just look around, you can see that there's a couple of holes. So if I come over to the fill single tool, up top here, there are 3 different filling algorithms to the hole fill tool. And then below there are 3 different approaches to filling. So filling the complete boundary, filling part of the boundary, or bridging the boundary. And then up top, it's the method that it's going to use to make up those missing triangles. So if I just click on a boundary, you'll see it'll automatically fill using that curvature-based method. Curvature-based method is probably the easiest to start out with, and then they have a tangent fill and then a flat fill. So flat fill is kind of obvious. It's going to try to cap off a hole with the flattest approach possible. And then with the tangent, what it does is it tries to maintain a nice smooth boundary edge tangent fill, but also maintaining a nice flat, less curvature approach to the fill method. And then this is an example of a fill partial. So you can come around and you can select from and to points and then select the side, and you'll see that it fills that boundary. And then on the bottom, if you wanted to mess with these, you can also do some fill partials here. But it's not necessary to fill everything because we're not really going to use all this. I just point out that these tools are here in case you need them. So after I get done hole filling, I almost always make sure that I run Mesh Doctor one more time. And there's a chance that it will find a few different areas with the hole fill. And then I go ahead and run that. And it should only take a second when you run it after you've finished hole filling, to repair any twisted triangles or anything like that. So now we have a data set that I want to extract geometry from. But before I can do that, if I click on the widget down here, you'll notice that the part is square, pretty square to the world axis. But if I come over to display and turn on the world coordinate system, you'll see that the coordinate system is way over here. So this is far away from the world coordinate system. So what we need to do is align this object to the world coordinate system. And with a fan blade, what I typically use is the axis, the central axis, and maybe the top plane. And then a lot of times I will grab one of the impeller blades and then fit a point there to index it. So I'm going to go ahead and create that geometry, and I'll show you how that works. So if I come over to model, what I'll do is come over and create a line based off this first option, cylinder axis. So you can come in and use the same tools that we use for selection, the lasso tool, but make sure that you turn off select through and toggle it back over to select visible. So you can window in areas like this to select that outer cylinder to create a cylinder axis. But what I like to do is use this option right here, this crease angle tool. What this does is when I click and hold with my mouse and drag up on screen, it will select more and less data. So you see it went all the way around and essentially grabbed all the faces that I want to use to create a cylinder axis and create that. So if I just hit next and OK, we just fit a cylinder axis there. Now the next step is to put a plane on top. So the top surface isn't as well defined because it's a pretty sharp, small little landing area. So what I like to do is I'll grab that lasso selection tool and I'll just click some areas on that top surface and do it this way because there's not enough, there's so much curvature there. There's not enough for that other method to work. And then this will give me enough averaging all the way around the outside that I can get a pretty good plane. Not only that, when I do the alignment here, I'm going to use that central axis as my main axis anyway. So that's going to be the primary axis of alignment. What I do now is if I right click in the open space on screen, you see that we do put the shortcuts for plane and cylinder. So if I click the plane, I can hit apply and you'll see that it best fits a plane to that surface. So then I'll hit apply and OK. Now, if I want to intersect those two, the axis and the plane, I can come over to point and you'll see plane and line. And then I can actually select that plane and the line that I created and then create a intersection point there. And the reason why I did that is I'm going to come over here and select a little bit of the tip there. And then I'm just going to say to fit a centroid point. And this is just to give me something to clock it to. I could use that. I could fit a line there if that line was straight. But in this case, I'm just going to use that point. And in this instance, I'm going to grab that point and come over to a 2-point line. And you can see I can click the from and to, and then hit apply, and it creates a line there. So there, I essentially created enough geometry to create a alignment. So now, if I come over to my tools and click align to world, the top is all of the things in the geometry already. So the X, Y, all these planes and axes, and even the origin. And then the floating is all the geometry that's on my model. So what we're going to do is we're going to click on that center point and the origin and create a pair. And we will do that one more time. We're going to create a center point and the origin. Actually, I think that's the issue is I clicked the line. So let's do that one more time here. So click on the point, the origin, create a pair. So now we locked in the wrong point. So I'm just going to go ahead and delete that one. So I clicked point 2. So if I click on point 1 in the origin and create pair, now you'll see the coordinate system is sitting on top of that axis there, exactly where we created that point. Now what I'm going to do is square up that axis to the other two pieces of geometry there. So now what I'm going to do is take that line and I'm going to say align that line with the y-axis, and it'll square that up. And then now, in order to clock it, I'm going to align the x-axis with my other line, that line 2 that we created, and it will square that up. And you see, since these stack on top of each other, the point, then the axis, and then that line, you see that those lines it's not locking those two together, it's only rotating it until it matches. Now when I hit OK, you'll see that it squares up the alignment of this part, and you can see that it's aligned to the world coordinate system. So now that I have that, I can go ahead and cut cross sections and create curves. So now begins the modeling portion of the demonstration. So what we're going to do is I'm going to cut a cross section through the center of the part, so I have enough geometry there to create that revolution or extrusion, depending on how I want to do it. And then we'll create geometry that represents that fan blade. So the first thing we're going to do is let's go ahead and cut a cross section. And you see I can actually toggle and change the cross sections over here. So I'm going to go ahead and use the YZ and slice through in that direction. And then make sure that the position is at 0. So it'll move it so it intersects the 0. Now down below you have an option. You can tell the software to cut a cross section through the polygon mesh with a spline, line arc, or polyline. So for a highly organic shape, I would use a spline, but for something that's pretty prismatic, in this case, I'm going to use a line arc option. And then I'm going to tell the software to go ahead and fit that, and I'm going to adjust the tolerance to like all the way down to like 1/1000th of an inch. And then when I hit apply, you'll see that it creates a sketch cross section through that geometry for me. And then if I hit next and OK, you see now that I have these curves. So if I hide that polygon, I have the curves cross section. So now if I toggle back over to the polygon mesh, the way we'll do the blade is this. I'll identify which blade that I'd like to use. So in this instance, I'm going to use this one, the one that I went ahead and used to align to the x-axis. And if I want to just send over curves to get those over into Solid Edge, the best way to do that is to come over to the model, and then there's this draw curves option. So you saw before I did create cross section through a mesh. Now I'm going to draw curves directly on the mesh. And this dialog can be a little bit confusing when you first see it, but if you basically use the first tool and then you look at the options down here on the left hand side, you can see that it's not quite as confusing once you understand a couple things. So if I click on the mesh, you can see that I can just draw curves on the surface of the mesh. And then once I get to a corner, if I hit escape, it will end that curve. Now, if I need to drag anything around, if I just roll over, I can drag the nodes of the spline. If I need to remove any of these nodes, if I hold Control, I can remove them from the spline. And then if I click back on, I can create a new one, but I need to hit Escape again to get out of it, because otherwise it'll start drawing another line. So speaking of that, if I just come over here and start drawing, I can create another spline and then hit Escape. And then again, you can always come back and manipulate the curves and move them around. So a red node is an endpoint that divides up multiple splines. So essentially, if a spline has all orange dots, it's all one spline. And then a red node like that means that's the beginning and end of a spline. So you can see that. And you can actually convert these points to using endpoints, and you see that all the options are down here below. So to try to get more accuracy here, I'll just create some cross sections through the blade. And you'll notice those red curvature collinear contours. What that is it's showing you that there is tangency there. So there's a shortcut here. If I click and hold and drag from one side to the other, I can turn tangency off or on. But they just show you that it's there or not, so you don't have to use them. In this instance, it's probably not that important because on the solid edge side, these are just going to be used as a guide anyway. So these are just to give me enough resolution to draw them inside of solid edge or convert them inside of solid edge. So you can see that I went ahead and I selected those curves and I drew them. Now, actually, let's go in and draw them on the other side because this isn't necessarily a constant thickness blade. If it was, I would just draw one side and offset the surface that I use, which, many of the companies that make these, they all know when they're designing it whether it's supposed to be an offset or a constant thickness blade. So I'll do the same thing, and I'll just come around. And then draw these. So let's undo that one and end that right there. And let's start that one again. There. Now I'll just draw these last few. There. And you can move these. So if I want to drag this out, it's really handy to be able to slide these around and add points. So if I add a point and then move this, so if I want it to follow the flow of the surface here. And once I'm done, I have the curves. The next step is to convert the curves to free curves. And in this instance, again, I'll lower the spacing to like 1/2 thou just to give it a little extra accuracy. And it's telling me that the highest it can do is 2 thou, which is fine. So now, if I hide this, I have curves. So when you use that convert to, it also converts the boundaries of the mesh. So if I don't want that, I can actually just click on it and delete it. The same thing goes here. So if there is holes in the mesh, those will show up in there. So I'm not gonna bother deleting that. It's nice to have that one just as an example to show where it is, but you can see all my curves. And then the other thing that you can do with this, so there's three types of geometry that we can extract from the model. One of them is prismatic features, which we used for alignment in this instance. The second one is cross-section curves. The third, actually four types of geometry, is cross-section curves and splines on the mesh. I guess you could create curves, whether they're 3D or 2D as one object. And then the other one is auto-surfacing the object. So auto surface will go ahead and wrap a surface around the outside of this object and create a CAD body that you can then export and send it over to Solid Edge. So now the auto surface is finished. So you can see the curves, the CAD solid, well, it's a surface, not a solid, and the features. So I can write all of these to an IGES file and send them over to Solid Edge. So if I grab all of these, I can save them out to an IGES. So that's the next step, is to go ahead and save these over to Solid Edge. So if I just come over to Save As, IGES, and I will just name my file. And write those out. It pops up with an export option dialog, so you can actually tell it to not write out the NURB surfaces if you don't want those, or don't want the features or curves. So like, you can choose what you want it to write, and then you can actually tell it to write in a single file. So I'll hit save. And now all you have to do is open that geometry inside of Solid Edge and use that to start modeling. So in the next portion of the demo, I'll show a little bit about the Solid Edge modeling and how you can take that geometry. I'm not a Solid Edge expert by any means, but I can definitely show you some of the basics to get that data inside of Solid Edge. So now for this portion, we're going to finish the part inside of Solid Edge. As you can see here on screen, I have the auto surfaced portion of the model and the curves in the same workspace. So if I turn off the surfaces, I exported the curves from Geomagic Essentials, and then I exported the auto surface. And what I did is I went over to the application and imported each IGES file from Geomagic Essentials and brought them in and saved out the part. Then I came over and I took one part and I copied and pasted it inside of another. That way we have both the curves and the surface inside of the one workspace. So now you can reverse engineer using the Solid Edge tools in whatever fashion you want to. For today, just to keep it simple, I'm not an expert in Solid Edge. So what I'm going to do is I'm going to use the curves to reverse engineer this part. And then I'm going to use the auto surface as a reference to see where I'm at and what I'm modeling. So the first thing I'm going to do is I'm going to go ahead and model the fan blade here. As you see, I have the curves that I brought in from Essentials. In order to do that, I'm going to come over to the surfacing tab and I'm going to create key point curves over top of the curves that I brought in. So you can see here that what I'm going to do is go ahead and bring and draw over top of nice clean key point curves. So in order to do that, I'll just come over to key point, and then you'll see I'm just going to draw right over this. And I may fast forward this a little bit so you don't have to watch me go over every single one. But I click finish on that first curve. Now, just to show you that I did do that, I'll turn off my initial curves and see that I drew that curve directly over top of the other ones. Now if I come over here and I just finish that one, again, one more time just to show. There we go. All right, so I drew the outside boundary. Now, if this was just a straight boundary fit surface, I would leave the inside pieces alone, but it's not. There is a shape to this inside. So I'll go ahead and grab these ribs that go across the middle and draw those. Now, if I go ahead and complete that, you'll see that I drew the entire surface here. So the top and bottom, again, this is where it's nice to have the surface in the background, are not exactly the same. It's not a consistent thickness surface on this blade. So now I'll go ahead and turn that off. That means I have to model the bottom side as well. But before I do that, we'll go ahead and create a bounded surface. So if I just select the 4 sides, and then I accept it. Now if I come over and I select the guides, I add these guides in, and then hit OK. So now you can see that I created a surface from that top area. Now if I turn on my curves again, or I turn on my surface, you'll see that I need to extend it past, because what I'm going to do is I'm going to extrude a top shape from here. I'm going to use the surface to trim the top and bottom. So what I'm going to do is turn that off, and then I'll hide my curves. Get rid of those. And then if I come over to the surfacing tab again and come over to extend, I can click on these boundaries here. And then extend those out just a little bit. So now if I turn that on, you can see that I extended that far enough that I can trim that top and bottom. So now let me go ahead and model that bottom side. I'll go ahead and model it and be back in a sec. So now you can see that I modeled the top and bottom surfaces. So what we're going to do now is, if you look at the part here, the main auto surface, you see that I'm just going to model a blade shape from the top down and then replace the face of the top and bottom of that extrusion. So in order to do that, I'll just go ahead and sketch on this top plane here, because this is already aligned to the world coming from Essentials. So I'll come over to sketching, and we'll go to line, and we'll go ahead and select this base plane here. And then I'll just click over to my view here and go to my sketch view. Now I can go ahead and hide those surfaces if I want to, and just model directly over top of the auto surface. So if I come over to sketching and use my line tool and just draw a line out in space, another line out in space here, we'll just reposition that. And then I'll go ahead and draw a circle from the middle, and I'm going to just draw it down the middle of this solid there. And you'll see here in a second why I'm doing that. And then we'll snap that to the outside. So with Solid Edge, I don't have to necessarily trim all these pieces together. I can just rough out my sketch and then get out of it and then come over and do an extrusion just using that profile and select what loop that I want to use. So if I come over to click on this area right here and accept it, and then let's extrude this 1 inch. So let's actually edit that and do like 0.95 there. And you see, you can use that as a reference to see. And make decisions reverse engineering how I want to. All right, so now I'm going to go ahead and use my surfaces. See that top surface and the bottom surface here. So if I come over to surfacing, there's a tool called replace face here. And what you can do is select the face that I want to replace, this guy right here with this one, and you'll see that it will trim that top surface there. And the same thing goes for the bottom. If I select that, accept, and then it will replace that face there. So now you see that I have my blade created. So from here, there's a few different things you can do. You could go ahead and pattern this now if you want to, or we can go ahead and draw the center. So if I come over here and I click on this and go to sketching, we'll go ahead and select that plane there. And then let's go to view, sketch view again. And this again is where the auto surface comes in handy. So you can come back over and turn that on. And let's create our inner and outer shape. So if I'll just create that, the outer and inner. And again, you can dimension it as you see fit. But you see that I just drew the two shapes. But you can redimension it like I just did earlier, and then come back over to extrude, grab this area here, and then extrude that. Let's do that 0.93. So there we have our shape. So now if I want to go ahead and turn off the curves, show the solid, now I can come over and just pattern the part to create a pattern of this blade around the middle. So in order to do that, I'll just come over to the pattern tool. So if I click on the object that I would like to pattern, the first protrusion, and you can see that I have the option to do a circular pattern over here. So I can select circular pattern. And then set it to 3. There I've created my circular pattern. Now from there you can do all your typical cleanup as far as adding rounds. And do all your modeling that you would normally do inside of Solid Edge. So that is a basic demonstration of how you can work with Geomagic Essentials to capture the data with the Shining 3D scanner use Essentials to auto surface and draw curves on the surfaces of the part, and then bring that data over to Solid Edge and finish modeling inside of Solid Edge. If you have any questions, my name is Greg George from 3D Systems, and we'll be happy to answer your questions. Thank you.